Hello and welcome back to Be Pharmawise. We have started the discussion of history of atomic structure, and in the last video we have discussed Dalton's atomic model and Thomson's atomic model, which is also called as plum pudding model. We also discussed how Thomson discovered presence of electrons as a subatomic particles. So let's continue this discussion, and today is the turn of a famous scientist and his name is Rutherford. In 19th century, after Thomson put forth his plum pudding model, Rutherford started to experiment a lot on the structure of atom, and he has designed a very famous experiment called as scattering experiment. What he did is he just designed a block where there was a radioactive element was put, and this was the lead box which was actually absorbing all the particles which were given out by that radioactive element. Mostly radium he was using, but there was a slit present there. Here he was having that radioactive element who was giving out so many particles, and only a few of them were actually passing by that slit, and these particles were nothing but alpha particles. Now what is alpha particle? It is actually the nucleus of helium atom. So it has atomic number of 2 and mass number of 4. It contains positive charge, so obviously alpha particles are positively charged particles. Now next what he did, he has taken a very thin foil of pure gold element, and he placed that pure gold foil in path of these alpha particles, so that those alpha particles will come and hit that gold foil. When he has placed that gold foil, simultaneously he arranged a photographic plate around the gold foil to observe what happens and what kind of emission happens, because in the photographic plate he will immediately come to know when a particle or ray of light will hit the photographic plate, there will be a spark. So now let's see what happens. What he was thinking is, he was having Thomson's plum pudding model in his thoughts. And what was the plum pudding model? As we discussed, Thomson said that there is a sea of positive charge. So positive charge is distributed equally and uniformly throughout the atom, and the negatively charged electrons are actually embedded inside the positively charged or positive charge, which is distributed throughout the atom. So what Rutherford was thinking is, he was thinking the atom as a piece of paper where all the positive charge is uniformly distributed, and he was thinking of hitting that piece of paper by bullets. Now bullets are these alpha particles which are being formed, and they are having a very high speed, and their positive charge is so compact and so powerful that the distributed positive charge over the entire atom will actually be like a piece of paper. So what he was thinking, if I hit this particular atom by a beam of alpha particles, my alpha particles should go in a straight path and they must hit the photographic plate here. So he was thinking like that, and he continued his experiment. And what happened, many of the alpha particles which were hitting the gold foil actually passed straight through, but to his surprise, a few of them were deflected with a slight angle, and a few, actually only 1 or 2 in 20,000, they came straight back. They were deflected with more than 90-degree angle. Now he was so surprised that how it can happen, how the rays can come back, how when I am hitting a piece of paper with bullet, how that bullet can come back and hit me. This is not possible. So this made him conclude that Thomson is telling something different than the reality. In reality, there must be something in the center where the entire mass is concentrated, where the entire positive charge is concentrated, and then he termed that central part where all the positive charge and all the mass of atom was focused or concentrated as nucleus of the atom. He said in the nucleus all the positive charge of atom is concentrated, and then electrons are actually present around the nucleus. So this was the theory given by Rutherford. This was the assumption given by Rutherford. Now in this process he has discovered nucleus, but he was so clever that he also discovered the another subatomic particle called as protons. Now let's discuss how he did it. So he observed his experiment and he concluded, or he actually observed, that when he was using various elements for hitting by alpha rays, he actually observed that if he hits the nitrogen nucleus, which is N714, with alpha particle, which is 2,4, then actually the nitrogen nucleus gets transmuted into an oxygen nucleus, oxygen 817, plus hydrogen nucleus is every time it is emitted. Now he repeated this experiment with several other elements, but every time the nucleus of hydrogen was emitted without fail. So this made him think that with every element, if hydrogen nucleus is getting emitted, it means hydrogen nucleus must be an integral part of nucleus of every element, and this led to the discovery of protons. Protons were the second subatomic particles discovered by Rutherford, and then he discovered the mass of proton and even the charge of protons, and he said protons are positively charged particles and they are nothing but hydrogen nucleus. So this is the discovery of protons, this is the discovery of nucleus. Now Rutherford didn't stop here. He went on searching a lot on atomic structure, and he was so clever that he found out the disparity between the number of subatomic particles and the atomic weight. See, at that time Thomson discovered electrons, and he said that mass of electrons is 1837 times less than the mass of proton. Then Rutherford discovered protons, and he discovered the mass of protons. So at that time only two subatomic particles were known, protons and electrons. So the weight of all these subatomic particles must be matching the weight of atom, but this was not the case. There was a clear difference between the mass of all these subatomic particles and the mass of atom. So Rutherford also has given the assumption that there must be one more subatomic particle present with no charge but considerable amount of mass, and that subatomic particle was later discovered by Chadwick and named it as neutron. In the next video we are going to study how Chadwick discovered neutrons and what are the other parameters of that subatomic particles. But wait, in this video we are also going to discuss the assumptions of Rutherford's atomic model and the limitations of Rutherford's atomic model, which led to development of Bohr's atomic model later on. So wait. So as we have discussed so far, Rutherford said that there will be a central positively charged nucleus where all the protons will be placed and the electrons will be present outside the nucleus. Now, what he said that electrons must be revolving around the nucleus in circular motion. Now, there is first limitation of Rutherford's model, which was the first objection to Rutherford's atomic model is, as per a common law of physics, if any body with charge on it, if any charged body is revolving in a circular motion in a particular path of radius, then over a period of time it loses energy. And as you know, once the revolving body loses energy, it will start to follow a spiral path and finally it will land up in the central nucleus. As the electrons are negatively charged bodies and as they are revolving around the nucleus, and over time if they lose the energy, they will follow a spiral path and will land on the nucleus because nucleus is positively charged. So obviously there will be a force of attraction towards nucleus, and if they are losing energy in such a way, they will land up on nucleus and thereby creating instability in the structure of atom. But actually speaking, atoms are quite stable. they are having a structure which don't essentially have this intrinsic instability in them. So this is something which was objectionable in Rutherford's assumption that electrons are revolving around the nucleus. People started asking him why they are not collapsing on the nucleus then. If they are a charged body and if they are revolving in a circular path, why they are not collapsing? But Rutherford was not having any answer at that time. Second problem was, he said that electrons are present around the nucleus and they are revolving, but he could not explain where exactly the electrons are revolving, where exactly they are placed, what is their position, and if there are more than one electrons present around the nucleus, are they having the same energy or do they have different energies? Do they follow different paths? Or what are their positions? So he was not having answers for all these questions at that time. So this becomes the second limitation of Rutherford's model, that he could not explain the energy and position of electrons. Okay, so first limitation was he was not able to explain the collapse of electrons on the nucleus, which was assumed by the law of physics, and the second limitation was he could not explain the energy and position of electrons exactly in the extranuclear part. So but the Rutherford's contribution in the history of atomic structure is so vast, it is unparalleled, and he has contributed a lot. He has discovered nucleus, he has discovered protons, he has also assumed the presence of neutrons, so he has done a great work. But then there was a discovery of wave particle duality, then there was discovery of other parameters, and considering all those developments, Niels Bohr came up with a better model, which we will discuss in the next video. So stay tuned for the next one, and if you are not subscribed, please consider subscribing and hitting that notification bell so that you won't miss that next video. Keep watching Be Pharmawise. Bye bye.